day, grade 12 learners. Welcome to today's mathematics lesson. My name is Tepang Mapotsani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12, in today's lesson, we are focusing on statistics. And for this topic in our paper 1, it weighs around 20 marks. By the end of this lesson, you must be able to identify and know the structure of paper 2. And for this lesson, we are going to specifically focus on the topic of statistics. Now, grade 12, let us go through our examination tips. And these examination tips, they will assist us by providing those effective strategies that we will need when answering questions relating to statistics. Now, grade 12, this is our structure for paper 2. And in paper 2, we have the 4 topics, and we are going to focus on the first topic that is highlighted there in red, which is statistics. And the weighting for this is 13% of our paper. That is, it contains 20 marks. And this question, it is found in question 1 and question 2. So the topic, it is tested in question 1 and question 2. Now, statistics. Now, in order for you to achieve maximum marks for this section, you must be able to, number 1, you must be able to calculate the mean, the median, mode, range, and standard deviation of a list of values. Number 2, you must be able to calculate the approximate mean, modal, class, quartiles of these values, including median of a grouped data. So what we are doing here, you must be able to calculate mean, median, mode, and range, and the standard deviation of an ungrouped data. And also, you must now give us the estimated mean, you must give us the modal class, and you must look at the quartiles where we are dealing with the grouped data. Number 3, you must be able to draw and interpret an ogive curve, which is our cumulative frequency curve. Number 4, you must be able to calculate the correlation coefficient and the equation of the least squares regression line of a bivariate data. Number 5, you must be able to estimate a value for bivariate data using a calculator or equation of the least squares regression line. This is called interpolation or extrapolation. So in this case, we are saying to you, we are going to utilize the equation of the least squares regression line, and we are going to use that equation to do what? To be able to find the value or estimate a value from that bivariate data. So remember, our regression line, it will be given as A plus Px. That is to say, you might be given the value of x and you must find y, or you might be given the value of y where you need to calculate for x. So we are going to calculate that using this equation, or we can just utilize our state mode in our calculator instructions to find those values. That is what we call, or that's what we focus on, interpolation and extrapolation. Number 6, you must be able to draw and interpret a scatter plot and with its line of bedsplit. Number 7, you must be able to comment on the relationship between variables and the reliability of a prediction. And in this instance, we are mostly focusing on the value of R, which is the correlation coefficient, and we are going to use the correlation coefficient to now comment on the reliability of a prediction that we can get from this working out. Now, for the statistics, you must remember that our section in an examination, it examines 3 types of data groupings. We are going to look at ungrouped data, where we are focusing on individual data values. Here, we are just going to look at points like 5, 6, 8, 20, proceeding in that order, right? And we are also going to look at our focus on the grouped data. These group data, these are data values that are arranged into equal intervals. So here we're going to have maybe an interval that says 0 is less than or equals to x, it's less than 5, then I can have 5 is less than the x there, and I can have 10. And in this case, these are the class intervals. And for these class intervals, we are going to now just say between 0 and 5, we have the data values that are 7. Between 5 and 10, we have data values that are 20. So this is what we are having the class intervals, and we are going to look at the frequency of the data values that exist for each interval. So we are going to look at the class intervals together with the frequency, and we will also go and focus on the cumulative frequency. Number 3, we are also going to focus on the bivariate data, and these are the data values that compare two variables. So for this instance, we are going to focus on the x and the y. So we are going to now interpret those two variables. And we need to note the following: the grouped data and bivariate data, it is commonly tested. So you need to make sure that you strengthen yourself when we are looking at the group data and the bivariate data. Remember, this bivariate data, it is the one that focuses mostly on the scatter plots. And we know that our grouped data, we are working with intervals and the frequency together with the ogive curve. But that does not mean you must disregard or forget about the ungrouped data. The ungrouped data, it is also examinable according to our examination guidelines. So you must make sure that we know much about them. Right. Ungrouped data, it is a data that consists of individual data values. These values can be given in a list in which the values are either ordered or not ordered in a frequency table. So here we are looking at whether we are going to look at an ordered set or the set that is not ordered. When we are looking at an ordered set, we are looking at the data values that are arranged in an ascending order. Then when we are looking at the data sets that are not ordered, we are looking at the data values that are arranged in a descending order or in any order for this matter. So it doesn't have to be descending order necessarily. It can just be those data values that are not arranged in any order, or these data values are found in a frequency table. For the ungrouped data, you need to be able to calculate the following measure of central tendency and spread. Number 1, you must be able to find range. Range, it is the difference between the maximum and the minimum data values. Let's say, for example, I have 5, 8, 20, 15, 48. Right. So if I'm looking at the range for me from this data set, I am going to have 48, which is the highest value. That is our maximum value. We are going to subtract it from our minimum value. Our minimum value, it is the lowest there at 5. Then we are going to take the 2 and we subtract them, and that is our range. Number 2, we are going to focus on the mean. So for an ungrouped data, you must be able to find the mean, which is the average of all data values. So with regards to the mean, we are now saying to you, add 5 plus 8 plus 12 plus 20 or plus 20 plus 15 plus 48. So 5, 8, 20, 15, and 48. Then to find this average, you're going to now divide by the number of these data values. These are 1, 2, 3, 4, 5. So we're going to divide by 5. So mean, when we're looking at the average, you add all the data values, and we are going to divide by the number of data values that I'm working with them. Number 3, we are going to look at the mode. The mode is the data values that occurs the most, or the value with the highest frequency. So when we're looking at the mode, we are going to look at a data value that occurs the most. So here I don't have any mode, but let's say, for example, I still have another 20 here. So I'm just adding that 20 so that we can look at the mode. So the mode, we can see that 20 occurs more frequent, as it appears twice in that data value. So the mode is the data value that occurs the most. A median, it is the data value that is in the middle of all values when the values are placed in an order, or when we are working with an ordered set. Then the median will be the middle value in this case. Right. Number 5, you must be able to find the lower quartile. This is the value that divides the values into the bottom 25 and the upper 75 when the values are placed in an order. This is very important. So when we are dealing with an ordered set, so we're going to look at the lower quartile. In simple terms, I normally say my lower quartile, it is the half of the first half. What I mean by that, I mean to say, I'm going to start by finding my median. My median will give me that median number. Then from that median, I am going to work with values from the first data point until the middle one, and I'm going to find the median of that value in that case. So that is our lower quartile in this case. So in this case, we know to find that position, we'll just say 1/4 multiplied by n. N is the number of data values. Then we're going to find its position. Then we're going to locate this position in our data set. Upper quartile, this is the value that divides the values into the bottom 75 and the upper 25 when the values are placed in an order. When we're looking at an ordered set, and the position of the upper quartile, it is going to be 3/4 multiplied by n, or I normally say you can just now take from the median until the last point and you find the middle value of that, then that is going to be our upper quartile. So here we are saying, let's say I have data values from the mean, I have Q2, I have Q3. Oh, let's start again and write it nicely. I have the values like a minimum value, I have our maximum, and I have my Q2. So my Q1, it is going to be the middle of minimum and Q2. So the middle value here is going to be my Q1, and my Q3, it is going to be the middle of my Q2 and the maximum value, and this is going to be where I find my Q3. Remember, we can just say the half of, or the middle value between the minimum and Q2 is Q1, and the middle value between Q2 and the maximum value, it is my Q3. So those are the values that we're going to focus on, or we can just use the position to locate those values in this case. Right, let's move on. Then we must be able to find our interquartile range. Our interquartile range, it is the difference between our upper and the lower quartile. So IQR, it's just going to be Q3 minus Q1. Right, then we must be able to find the standard deviation. This is the measure of how spread out are the data values, or the spread out of the data values in relation to the mean, to say our data values spread out, or how are they spread out around the mean? Are they close, or are they far from each other, or far from the mean in this case? Number 9, we are going to say how many data values are within. So we must find how many values are within the 1 standard deviation from the mean, within 2, within 3 standard deviation, or those values that are inside or outside the standard deviation. Right. Let's just go back. Right. To find the mean and the standard deviation, we have our calculator instructions rituals. We are not going to go through these instructions line by line, but this is our third mode that we are supposed to learn, and this is part of my book work. You must make sure that you master this state mode. Now, statistics in terms of the group data. The group data, this is data values that consist of values that are organized into equal class intervals. These values can be given in a frequency table or cumulative frequency graph, which is the Hogarth curve. And for the grouped data, you need to be able to calculate the estimated values. So here, because we're dealing with the grouped data, we were working with the estimated values of the following measures of central tendency and dispersion. Number 1, you must be able to find our mean. The mean, it is the average of all data values, but because we are looking at estimates, then we are saying, but since we don't have actual values, we use the midpoint of each interval as an estimate of the values in that interval. So here we're working with the class intervals and the frequency. So we are going to find the average mean by working with the midpoint of the class interval as an estimate values, or estimate of the values in that interval. Number 2, we must be able to find the median, and to find the median, it is estimated using the ogive curve. So we just need to locate the median. So to locate the position of the median on the y-axis, we are going to say 1 over 2 multiplied by n. N, it is our total frequency. Then the answer that I get is going to be the position on the y-axis, and I can just work from that y-axis, draw a line from that y-axis, and I drop it to my x-axis. Then that is the value that I'm looking at on the x-axis. Number 3, we are going to look at the modal class or modal interval. This is the interval that has the highest frequency. So in my frequency table, I just look for the class interval that has the highest frequency. That is going to be my modal class. Number 4, you must be able to find the lower quartile, and the lower quartile, it is also estimated using the ogive, and we're going to find the position as 1 over 4n, and this value we find it on the y. Then we're going to now draw the line and extend to the x-axis. Then our answer is going to be on the x-axis. Then we must be able to find an upper quartile using the ogive again. So we're going to use the ogive to say 3 over 4. Then we are going to find the position on the y. Then we are going to extend that to the x and find that value. And we are going to look at the interquartile range. The interquartile range, again, it is still our difference between the Q3 and the Q1. Then for grouped data, we must now look at the 2 types of group data. We have discrete data. This is data that consists of items that can be counted, e.g. number of people. So when we're dealing with discrete data, so we are saying we are looking at number of people, for example, to say there's 1, 2, 3, 4, 5 people, for example. When finding the midpoint of the discrete data, we don't include both the endpoints of the interval. So if, for example, we're having 5x, then 10, then we are going to include those, the endpoint of that interval in that case. Continuous data, this is data that consists of data that can be measured. For example, liters of petrol. To say, I can say, to measure petrol, I will say I have 5 liters of petrol. I can't say I have 5 petrols. So it wouldn't make sense. So this is a continuous data. So it must have a certain scale or a certain measure to say I have 5 liters of petrol. This is a continuous data. When finding the midpoint of the continuous data, we can include both the intervals of our interval, both the endpoints of our interval. So to say we're going to include that 5 and the 10, then we're going to find the middle value between the 2. Right, bivariate data. Bivariate data, remember, this is the data that consists of 2 variables. The word by there, we are looking at 2 variables. And remember, these variables are our x and one we're going to assign on the y. And we are going to say the strength and the type of the relationship between these 2 variables is usually the focus on this question. So on this question, we are mostly going to focus on the strength between the x and the y variables, and we're going to look at the type of relationship that exists between x and y. For bivariate data, you need to be able to calculate and comment on the following. Number 1, you must be able to find the correlation of coefficient, which is R. This is the measure of how strong the relationship or the correlation between the variables is. Remember, our R in this case is given, it is found between, R is between -1 and 1. And when R is closer to 1, we have a strong negative correlation. When R is closer to a +1, we have a strong positive correlation. And in the middle, when R is around 0,3 and 0, we are having a weak positive correlation. When it's -0,3 and 0 in this case, we are having what? A negative, weak correlation. And for this bivariate data, again, you must be able to find the equation of the least squares regression line. And this equation, remember, is going to be given to us in our formula sheet. And the equation is as follows: it's y equals to a plus bx, and this is the equation of the line of best fit when the data is represented on a scatter plot. Then we are going to look at interpolation. We are going to say this is an estimated value within the data range. and extrapolation, this is an estimated value that we find outside of the data range. So if my data, it is ranging between 5 and 20, interpolation, it is any value that we are going to estimate between 5 and 20. And for the same data between 5 and 20, extrapolation, it is a value that is either outside above 20 or below 5. It is outside our data range. And grade 12, this is our state mode that we utilize to work around the bivariate data. This will also help us to find the equation of our regression line. It will also help us to find our R, our B, and our A. In that case, it also helps us to find our mean, but also it will help us with our standard deviation in this case. So this, again, grade 12, it is part of our book work. So we must ensure that we have mastered these calculator instructions before going into the examination. And this is our formula sheet. And our formula sheet, we must know that for the statistics, we are going to work around our equation of the regression line. Then we are going to work our standard around our variance, and we are going to work with that mean in that case. Now, grade 12, that brings us to the end of our examination tips. Now, let us now apply these examination tips, and we can now look into our exam questions. Now, we are having question 1 from November 2023, paper 2. And for these questions, grade 12, I will give you 5 minutes to complete this activity. And your 5 minutes starts now. Welcome back, grade 12. Let us look at question 1. The question reads as follows. Truck drivers travel a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. So we are looking at the distance traveled, and we are also looking at the amount of time rested in minutes. So those are our variables that we are going to look at. The information is given below. So we are given the distance traveled in X and the amount of rest time as Y. So we are supposed to represent the above information in a scatter plot. Let's go to our scatter plot. Now, to represent the information, the first thing that we are going to work around, it is to look at the amount of rest time. So we are going to now have this as our Y because it says in our Y. So we're going to represent this on our Y axis. We are going to represent the distance traveled on our x-axis as it is indicated for my question in that case. Now, to just draw the scatter plot, we just plot each and every point that you see right here. And how are you going to do it? We are going to look at x. When x is 180, so x is going to be 180 around here. Then y is going to be 20. So that is where y it is 20. We proceed. When x is 200, then y it is 25. So 25 is going to be around that point. Then when x it's 400, so this is x 400. So you just plot each and every value in any order you like. You say when x is 400, then y is 55. So 400, then my y it is going to be 55 there. Then when x is 600, then my y it is 120. So that is where 120 is. It's on that line right here. When my x is 170, then my y it is going to be 15. Then when x is 350, then I have my y as 50. So you can see that 50 is found between 40 and 60 then when my x is 270, my y it is equals to 40. Right, so that is the value right there. Then the data point of 300, when x is 300, then my y being 45. So you just plot each and every point in that order. So you don't have to have a particular order, just plot each point as you proceed with a table like that. Now, the 12th, let us look at 1.2 and 1.3. And for these two questions, you are given 5 minutes again to complete 1.2 and 1.3. And your 5 minutes starts now. Welcome back, grade 12. Let us now focus on 1.2 and 1.3. 1.2, it reads as follows. Determine the equation of the least squares regression line for the data. To find the equation of the least squares regression line, we are going to utilize that calculator instruction. And when we utilize the calculator instruction, I'm going to find the value of A from my calculator. My A, it is equal to negative 23,85. My B, it is equals to 0,23. Then I'm going to code the formula that says Y it's equals to A plus BX from my formula sheet. Then I'm going to substitute my values of A. A is negative 23,85 and B, it is 0,23 X in that case. So that is my equation of the regression line in this case. So the marks there, you're going to get 1 mark for A, 1 mark for B, and 1 mark for the whole equation being correct. Number 1.3, we are supposed to draw the least squares regression line on the grid. To draw the least squares regression line, remember this is a line that is going to pass where most points are. So I'm going to draw it there as it passes where most points are, and make sure that the line passes through a mean value, or a mean value in this case. Now, grade 12, let us look at 1.4 to 1.6. And for this question, grade 12, you are also given 5 minutes to complete 1.4 to 1.6. And your 5 minutes starts now. Welcome back, grade 12. Let us look at 1.4. 1.4 is as follows. If a driver travel 550 kilometers, predict the amount in time in minutes that he should rest before continuing his journey. So we are looking at the question that involves interpolation and extrapolation. So what's important with regards to this question, it is to know whether am I given X or Y. Then I'm going to use the least squares regression line to actually calculate for the variable that they are looking for. So they told me in 1.4 that a truck driver has traveled 550 kilometers. We stop there. What is 550? My 550, it is the distance traveled, and it is found on the X. So my X in this case, my X, it is going to be 550. And it says, predict the amount in time. So the amount in time, we're looking at the amount of rest time in minutes in this case. So what they are looking for, it is Y. How do I know it is Y? Because the amount they want me to predict, it is the variable, or it is represented on the variable Y. So I'm looking for the Y. So in my least squares regression that I found in the previous question, I will substitute X as 550. So where X is, I'm going to place 550. Then again, to find my Y, place everything in a calculator. My Y, it is equals to 102.65 minutes in this case. As you can see, we were predicting within our range because the lowest value is 180 and the highest value in this case was 600. So we were predicting within, so this was interpolation, and our Y is going to be interpolated at 102.65. Write down the coefficient of correlation for the data. To find this R, remember we are going to utilize our calculator instructions, and our R, it is going to be 0.98. Now let us proceed to question 1.5. For question 1.5, it reads as follows. Write down the correlation coefficient for the data. Now to find the correlation coefficient for the data, we are looking for the value of R, and our R in this case is going to be 0.98. Now this correlation of coefficient, which is R, remember we are finding this value using our calculator instruction to find that R. Remember, when we are using that state mode, we are able to find the R from our calculator. 1.6, it reads as follows. Interpret your answer to question 1.3. To interpret this answer, grade 12, remember, we are going to now look at R to say, remember our R, this is a value that lies between +1 and -1. Now to interpret the answer, we see that our R was +0.98, and +0.98, it is closer to 1 or to +1. So my interpretation will be there's a strong positive correlation. Remember, when I go closer to +1, I have a strong positive correlation. And when I go closer to -1, I have a strong negative correlation. So here R was 0.98, which is positive 0.98. It is closer to +1. Now, grade 12, I will give you 5 minutes to look at question 1.7 from 1.7.1 to 1.7.3. And for this question, grade 12, as I have mentioned, you are given only 5 minutes to complete these 3 questions. Welcome back, grade 12. Let us now look at 1.7. 1.7 reads as follows. At each stop, the truck driver spent amount of money buying food and other refreshments. The amount spent in rents is given in the table below. So we are given 100, 150, 130, 200, 50, 180, 200, 190. So we are given individual data values, and we are required to say calculate the mean of the amount of money spent at each shop. Let's look at this calculation. So remember, to find this mean, I will say 100 plus 150 plus 130. So to find the mean, we are just going to add all these individual data values, plus 200 plus 50 plus 180 plus 200 plus 190. Then I'm going to divide by the total number of data values. They are having 1, 2, 3, 4, 5, 6, 7, 8. I'm going to divide by 8. When I add all of them together as 1,200, the total is 8. Then I have my mean as how much? My mean is going to be 150. Let's look at 1.7.2. 1.7.2, it reads and says, calculate the standard deviation for the data. We are dealing with our ungrouped data. These are individual data values. We are going to utilize again our calculate instruction to find the standard deviation. And from my calculate instruction, the standard deviation will be 50,50. Let's proceed. 1.7.3, it says, at how many stops did the driver spend amount of money which was less than 1 standard deviation below the mean? Now, to work around this type of a question, when we are dealing with the standard deviation below the mean or above the mean or within the mean, we must find our limit, and we know that our limit is going to be, our lower limit is going to be mean subtracting the standard deviation. So we are looking at the number of stops less than 1 standard deviation. So these are the ones that are below 1 standard deviation. So the mean is 150 minus 50,50 in this case. Then we are going to check how many data values are below. Remember, this is less than. So we're looking for any data value that is below the 1 standard deviation of the mean. Then what are we going to look at? So our value is 99.50. So we're looking for any value that is less than 99.50, and the value is going to be 50. So how many stops are we having here? We only have 50, which is 1 stop in this case. That is the stop of 50. Right, now grade 12, let us go and look at question 2 from November 2023. And for this question, grade 12, you are given 5 minutes to complete from 2.1 until 2.3. And your 5 minutes starts now. Can I just check a message? Can I check a message quickly? Welcome back, grade 12. Now let us look at question 2 from November 2023. The statement reads as follows. At a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during the school day, and all teachers were present on a specific day were interviewed. The information is shown in the table below. So the information that works around number of glasses of water drank per day in our class intervals. So we have those 1, 2, 3, 4, 5 intervals, and we are given the number of staff members. This number of staff members, remember, this is our frequency to say between 0 and 2, how many staff members drank the glasses between 0 and 2? It is going to be 5 in that case. Between 2 and 4, how many staff members? There are 15. Between 4 and 6, there are 13. Between 6 and 8, there are 5. between 8 and 10 classes, there are 2. The first question, it says, complete the cumulative frequency column in the table above. To complete that table, remember, to work around the cumulative frequency, I take the first frequency, I place it as it is there, then I will now say that value plus the 15. So I'm going to say 5 plus 15, then the answer I'm going to write it on the next column. I have to say 5 plus 15 is going to be how much? 20. Then I take that 20 again, I'll add it with the 13. So say 20 plus 13 is going to be 33. Then I write it there. Then I say my 33 again, I'll take it. I say 33 plus 5. So I'm working with that zigzag motion there. To say 33 plus 5, it gives me 38. Then 38 plus 2 is going to be 40. Let's look at 2.2. 2.2, it says, how many staff members were interviewed? So we're looking at the total staff members that were interviewed. So we are going to just add all of these values here. To say 5 plus 15 plus 13 plus 5 plus 2, it is going to be 40. Or we just take the last value of the cumulative frequency there. So that is 40. So the total, we add all of the values under frequency. So we are adding under frequency, or we take the last value of the cumulative frequency. 2.3. How many staff members drank fewer than 6 glasses of water per day? So fewer than 6 glasses, this is where we are. So we are looking for all of those staff members that are in the interval of 0 and 2, 2 and 4, and 4 and 6. So what we are going to do for that part, so for this part, what we're going to do, remember we're saying we're working from around this interval. So we're going to add the 5 plus 15 plus 13. So we're looking at those that are fewer than 6. So it is from that interval going up. So this is going to be 33 staff members. So the answer is going to be 33 staff members for that question. Now, grade 12, we have 2.4. And for this 2.4 question, we are given 5 minutes to complete that 2.4. And your 5 minutes starts now. Welcome back, grade 12. Let us look at 2.4. 2.4 reads as follows. The staff committee observed that K teachers were absent on the day of interviews. So K teachers were absent. It was found that half of these K teachers, so the half of the K teachers drank from 0 to fewer than 2, which is 0, between 0 and 2, and glasses of water per day, while the remainder of them drank from 4 to fewer than 6 glasses, which is, so the remainder drank between 4 and 6 glasses of water per day. When these K teachers are included in the data, the estimated mean of the glasses of water per day per staff members per day. And the question reads, how many teachers were absent on the day of interviews? Let us go back again. The staff committee observed that K teachers were absent on the day of the interviews. It is found that half of these K teachers drank from 0 to fewer than 2. That is 0 less than or equals to X less than 2 glasses of water per day, while the remainder of them drank from 4 to fewer than 6. That is 4 less than X less than 6 glasses of water per day. When these K teachers are included in the data, the estimated mean, so our estimated mean went to how much? 4 glasses of water per staff members per day. How many teachers were absent on the day of interviews? So these are K teachers, so we just need to know what is the value of K. Now let us interpret this question and understand what it means. We are told that these K teachers, half of them, they drank from this part, to say half of them were here. So this is half of K teachers. They drank from 0 to fewer than 2. And they said the remainder, remember, to make k, it is half plus half, which is going to give us k. So the remainder, the rank from 4 is less than or equals to x or less than 6. Then plus again 1 over 2 k of that 6 in that case. So this is how we are going to effect the value of k in that case, that right there. So let's go back again to say we're told that half, which is 1 over 2 of k, is just k over 2. They said they were from 0 to 2, and 4 to 6 again it was half of k again, which is k over 2 in that case. Now to find the estimate mean, remember, we are going to take the midpoint, we are going to multiply it with our, we are going to take our midpoint and we multiply it with our frequency in this case. So the midpoint between 0 and 2 is 1. The midpoint between 2 and 4, it is going to be 3. The midpoint between 4 and 6, it is going to be 5. The midpoint between 6 and 8, it is going to be 7. The midpoint between 8 and 10, it is going to be 9. So what we are going to do, we're going to take 1, we are multiplying by the frequency. The frequency is going to be 5 plus k over 2. So that's midpoint times frequency. So the midpoint is 1 times the frequency. Then we take the midpoint here, it was 3. We multiply it by the frequency, which is 15. Then we get 3 times 15 there. Then we take again the midpoint, which is 5. We multiply it by our frequency, which is 13 plus k over 2. So 5, which is the midpoint, times 13 plus k over 2. Then we take another midpoint here, which is 7. We say 7 multiplied by its frequency, which is 5. It's going to give us 7 times 5. We have again our midpoint for the last interval then, which is 9. We multiplied with the 2. Then we're going to get 9 times 2 in that case. Right. Now, we need to now notice the effect of that cumulative frequency to say, when I add up these values, I get 40, then there is k over 2 plus k over 2. And this is going to be 40 plus k. Then that is our last value for the cumulative frequency. We just effect that k that was absent. Right, now to find our value, now remember they told us this mean we are going to now add all of these values, 1 2 3 4 5. We add all of them, we divide by the total. Our total, remember, it is 40 plus k, it's equals to 4, because we were told that the mean is equals to 4. Remember, the 40 comes from 40, then it's k over 2 plus k over 2, which is now 40 plus k, which is what we're having right there. Then from here, we can solve for k. And how to solve for k? We can cross multiply. This is over 1. Then we can just say we are going to have 40 plus k. We're going to have 40 plus k multiplied by 4. Then 40 times 4 is going to be 160. 4 times k is going to be 4k. Then we are going to also simplify what is at the top there. So we are going to simplify everything that is at the top right there. Then we are going to have 5 plus k over 2 plus 45 plus 65 plus 5k over 2. When you simplify this part and that part, then we have 35 plus 18. Then when you solve for k, we get 3k equals 2. So this side we're going to get k over 2 plus 5k over 2 again. So those are like terms, we add them together. Then we add the numbers of 5, 45, 65, 35, and 18. We get 168 is equal to 160 plus 4k. Then to find k, our k is going to be 8. So the number of teachers that were absent were 8. Now, grade 12s, let us look at question 1 again from November 2022. And I will give you only a minute to copy down this statement and our scatter plot, or just take it down. Or rather, let's have 2 minutes for this one. Then let's move on. And these are the questions we are going to have for this question. So from 1.1 to 1.3, you are given 10 minutes to complete those questions, and your 10 minutes starts now. Welcome back, grade 12s. Let us go through our statement first. The statement reads as follows. The matric class of a certain high school had vote for the chairman of the RCL. The representative council of learners which is RCL. The scatter plot below shows the IQ, which is intelligent quotient of 10 learners who received the most votes, and the number of votes that were received before the election, and the popularity of each of these 10 learners were established, and the popularity score out of 100 was assigned to each. The popularity scores and the number of votes of the same 10 learners who received the most votes are shown in the table below. So we have the popularity score, which is on the X, and we are given the number of votes as Y. And this already, they've drawn a scatter plot for us. So you have a scatter plot that is number of votes versus our intelligent quotient there, which is IQ in that case. Right. Now let's move on. 1.1 reads as follows. 1.1, it says 1.1.1, calculate the mean number of votes that these 10 learners have received. Now, to find the mean number of votes of the 10 learners, this is what we are going to do. So we are looking for the mean for the number of votes. So the mean is centered around the number of votes. So we are going to look at a number of votes as our data that we're going to look at. So to find the mean for the number of votes, which is Y alone, we're going to say 9 plus 22 plus 10 plus 21 plus 11 plus 15 plus 20 plus 12 plus 19 plus 16 divided by the total number of those learners. There were 10, so divide by the 10, and our mean is going to be 155 over 10. Then our mean is 15,5. Let's look at 1.1.2. 1.1.2, we're required to find the standard deviation of the number of votes that these 10 learners received. So we're looking for the standard deviation for the number of votes again. So we're still focusing only on the Y, which is number of votes. So we are going to use our state mode, and we're only going to apply the state modes for the number of votes in this case to find the standard deviation using our calculator instruction, and the standard deviation was found to be 4,59. 1.2, it reads as follows. The learners who received fewer votes than one standard deviation below the mean were not invited for the interview. How many learners were invited? Let's read again. The learners who received fewer votes than one standard deviation below the mean were not invited for an interview. How many learners were invited in this case? So to find the learners that were invited for the interview, we are going to look at our limit in this case. We are going to look at our upper and lower to say, okay, our lower limit in this case, we are going to say the standard deviation or the mean subtracting our standard deviation in this case. And we are going to have the 10,91 in this case. So we are going to check how many were not invited. So remember, we were told that those who received fewer than one standard deviation were not invited. So we just need to know how many learners were invited in this case. Right, so not invited, let's check how many are there. So we are going to check not invited, they are below 10,91. So how many values are below 10,91? We can see it's going to be 9. This is above, this is above, this is above, this is above, this is above. Oh, this is above, and this is also below 10,91. So it is 9 and 10, and all of these other values are above the standard deviations. So the number of learners that were not invited were 2. It is those that are at 9 and 10. And those who were invited, which is when we are answering our question. So invited in this case, it is going to be 2 minus 10. It is going to be 8. So for this one, we are going to say 10 minus 2, the 2 that were not invited, which is those that are below 1 standard deviation, because below that 1 standard deviation, those were learners that were not invited, they were 2. Then we are going to have 8 learners were invited in this case. Right, 1.3, it reads as follows. Determine the list of squares regression line for the data in the given table. Now we are going to look at, or we are going to focus on both X and Y. We are going to utilize our calculator state mode instructions to find the least squares regression line for the data. and we're going to place both X and Y values. Then we find that our A from our calculating instruction is going to be 1,77, and our B, it is 0,22 in this case. Then from our equation that says Y is equals to A plus bx, we substitute A as 1,77 plus B, which is 0,22 multiplied by the x, and that is our equation. Our equation is going to be 1,77 plus 0,22x. Now, grade 12, let us now look at 1.4 in this case. So for 1.4 and 1.5, I will give you 5 minutes to complete 1.4 and 1.5. So 1.5.1 and 1.5.2. And for these two questions, you have 5 minutes. Start now. Welcome back, grade 12. Let us look at 1.4. 1.4, it says, predict the number of votes that the learner with probability score of 72 will receive. Now, let us look at what we are given and what are we supposed to predict. Now, let's check. It says predict the number of votes. Okay, so what are we predicting? Y. So number of votes you can see from our table is Y. So we know that Y is going to be unknown. That the learner with the popularity score, so we are given the popularity score of 72. Our popularity score, we can see it is represented on the X in this case. So our X is going to be 72. So from my least squares regression line, I'm looking for Y. I'm going to substitute X at 72. Then I find my Y to be 17,61. So my prediction to say the number of votes that a learner with 72 popularity score will get will be 17,61 votes. And that is approximately 18 votes. Right. Then 1.5, it reads as follows. Using the scatter plot and the table above, provide a reason why the IQ, it is not a good predictor for the number of votes that a learner could receive. Now, what are we going to look at here? We are going to look at our scatter plot. Our scatter plot, we can see, we are not seeing a clear correlation here. The values are scattered around. So we can say all points are scattered, therefore there's a low correlation, and we have an unrealistic prediction. So we are having R as being very low in this case. So that is why we are now saying to you, IQ won't be a good predictor in this case because we have a low correlation in that case because the points are scattered above below. So we need to find R in this case. We can use the value of R to comment them. Right. Now let's look at 1.5.2. 1.5.2, it says the prediction in question 1.4 is reliable. Right. So is the prediction 1.4 reliable? Yes. So we are going to look at the R with regards to that. So our R in that case was 0.98. So the one in 1.4, what we see is that there is a strong positive correlation. Because of the strong positive correlation, we have now a reliable prediction. So low correlation, we are having an unreliable prediction. Then for a strong correlation, we are going to have a reliable prediction. Now, grade 12, let us proceed to question 2 for November 2022 paper 2. And we are given an ogive and we are given a statement then. And for these two grade 12s, I will give you 2 minutes to note it down. You can even take a picture of that ogive and get the statement down, or you can just draw the ogive curve with those points that are there. Right. So for this question, I will give you 2 minutes to just copy down our statement. Now let's proceed. Now, these are questions from 2.1 until 2.5. And for these questions, grade 12s, I will give you 10 minutes to complete 2.1 until 2.5. And your 10 minutes starts now. Welcome back, grade 12s. Let us look at 2.1 until 2.5. Now, 2.1, it reads as follows. How many people were employed at this company? So to answer for 2.1, we are just going to check what is the highest value there in our cumulative. So we can see that our highest value was 60. So the number of people that were employed here was 60 employees. 2.2, it says write down the modal class of the data. And to find our modal class of the data, so we are going to look at the modal class of the data is going to be from 20 to how much? To 25. As we can see that we are having a longer graph between the two, and we have more data values between 20 and 25. So that is where we are going to have our modal class of the data for this activity. How many employees spend more than 22.5% of salary on their fuel? Right. So those employees that spend above that, it is more than 22.25 in this case. So 22.25, so 22.25, it is somewhere above those values. So it's going to be between 60. So we're going to have 60 there, because for 60 we are going to have that 35 in this case, and between this is 20, so this is going to be 20, the half of 20, and that is going to be 23 in that case. So now this is going to be 20 and a value that is above that, so it's going to be that 30, 31, 32, 34 is going to be the value in the middle. Remember, it's more than 22.5, so 22.5 is from 23. So it's from that 23, so we are going to say it's between 23 and 35. That is where our value is going to lie. And now the number of employees is found on our cumulative part, so we are going to take this value, which is going to be 34. Remember, it's 30, 32, 34, 36, 38, 40 in that case. So we're going to take that 34, or the 60, subtracting the 34 that we have there. Then we are going to say there were 26 employees. So we can see more than 22.5, it is from 23, which is the value there on that line, then until the 35 in that case. Then 2.4, it says, an employee spent 2,400 of his salary on fuel on a particular month. Determine the monthly salary that of this employee if he spends 7% of his salary on the fuel. So to find the salary, we are going to say, remember, we're told that this person spent 2,400 of his salary on fuel. So this 2,400, it is for the fuel. So the 2,400, we're going to multiply by 8 to say this 2,400 represents the 7%. So going to be 2,400 multiplied by 100 over 7. So the overall salary we know is going to be 100. Then we are going to say we are looking for the 100% of the 7% of 2,400, and that value is going to be 34,285.71. Or the easier way you could have done this, what you could do for this question, we can simply just take the following and say, okay, I am going to say my salary is equals to my fuel in this case. And my salary, I said, I've spent 7% of my salary. So I can say my salary is X, and my fuel, I spend an amount of 2,400 in this case. But from this salary, I didn't spend all of the salary. I spent 7% of it. And 7% is just 7 divided by 100, which is 0.07x. Now to find x, we are just going to divide by 0.07. We divide this side by 0.07. Then our x, it is going to be the value that we found from the previous question, which is now going to be 34,285.71. Right, so that is the value that we're going to get to say. We are going to say salary is equal to fuel. My salary, it is X, but I know I spent 7% of this X, so it's going to be 0.07. It's equals to 2,400, which is the price of the fuel. Then to find X, we divide by 0.07 to 0.07. Our X is going to be 34,285.71 for that answer. Right, let's move on. Now 2.5 reads as follows. It says the monthly salaries of these employees remains constant. So the salary does not change. And the number of liters of fuel used in each month, it also remains constant. The fuel price increases from 21.43 to 22.79 per liter at the beginning of the next month. How will the above ogive change? Right. So what we are going to see is the following. So we can see that now the salary remains the same. So the salary, let's say for example, we are going to use the question in the previous question. Our salary will remain at, let's use that person to say it's going to be 34,285, and only the fuel price is going to increase. If the fuel prices increase and the salary remains the same, what is going to happen is that all of these data points are going to shift to the right, because the percentage of that fuel, it is now going to know, it's no longer going to be the 7. So the percentage of the fuel, it is now no longer going to be 7, it is going to increase. So all of these data points will shift to the right for this question, where our salary remains the same at 34,285. Let's say I'm using that person as our example. So because the salary remains the same, only the price increases. That means the percentage on salary of salary on the fuel, it is also going to increase. So the points will all shift to the right. So the percentage won't be 7, it might be maybe 7.8, 7.5 going up there. So it's going to be more than 7, and the value is not going to be 2,400. Maybe it will change to 2.8, 2,800 for example. So when the fuel prices increases from 21 to 22, we notice that the amount spent on fuel is going to also increase. And when that increases, the percentage on fuel will also increase. Then all of the data points will shift to the right to show you that there is an increase in the percentage on the fuel in this case, where the salaries remain constant. So we are saying the ogive or cumulative frequency graph will shift to the right, or it will become steeper. Right, grade 12, this brings us to the end of our lesson. And for our next lesson, we are going to focus on paper 2 revision, part 1. And for this next lesson, which is our revision of paper 2, we are going to focus on analytical geometry. Thank you. Enjoy the rest of the day.